All right, this is a continuation of the notes from class today. So we are looking at the ones where we are trying to figure out, from what we've already learned, the frequency table is a count of how many items are in each value group. So like for that part A right there, the value in our data set is 5, and there were 2 of them in the data set. So that's what that means. And then what we've learned about the histograms, essentially the bar graphs, the shape of our data. So our data is either going to be, remember, symmetric or skewed. It's either going to be skewed possibly to the right or to the left. That just means the center, if we look back at our picture from in class, is not perfect right here. So see, this first type is symmetric. And then the second two, this one is skewed to the right because there's a lot of data pulling us away from the center on this side, but not so much on the other side, on the left. And this one we're skewed left because there's a lot more data pulling away from the center on the left than there is on the right. So just a reminder of those three shapes essentially. So this question, this type on the homework, it's just saying, is it skewed or not? So we don't necessarily have to be able to tell if it's right or left on these problems. We're just asking, is it skewed? And now, and they're wanting you to do that without doing a mean, median, or mode. And they said you could sketch if you want to try and answer the question. So that's a possibility, but you don't actually need to sketch. So I want to show you kind of how I look at these. So what you're going to look for when you try to figure out which shape these has is you're going to find the highest frequency. That's supposed to be the peak of our histogram, the top bar, the highest one in our bar graph. So if you look right here, it looks like this is the most frequent. So that should be the peak. And what I normally do is I look on either side of it. If those two numbers on either side are also very similar to each other and not too far away from this number, I kind of consider this to be our peak, our complete peak in the graph. Okay, now I will graph this one in just a second, just to show you that this is how this works. Okay, now what you're going to do is you're going to look at how much is to now, and a lot of times you have to think of this because this is like turned sideways for us. This is on a number line. So 5, 6, 7, 8 are all less than the 9, 10, 11, and 12, 13, and 14 are all greater than. So this would be the values to the left of our center, and the ones going bigger than our 9, 10, and 11, those are going to be the ones to the right on our number line. So we're going to say, how many values are to the left and then how many are on the right. Now, once you've located your center, which is, like I said, the peak, and then you're looking at just these other groups, the left side and the right side of your, like where your bar graph would be. If those two groups, if the left side and the right side are pretty much almost the same exact value, you're going to have symmetric data. If one group is much different than the other group, in other words, you have a lot more frequency in that group, you're going to have skewed data. Okay, so let's add these up. So that's 2 plus 5 plus 9. This is just how many we have of each of these numbers. And then plus 15. So that would be 20 plus 11, so that's 31. So there's 31 items to the left of my peak. Okay. And then I'm going to add up these. I have 15 plus 10 plus 4. That's going to be 29 items to the right. Now, those are not exactly the same, but they are very, very close. So this graph is going to be symmetric. So this would be, the question was, is this skewed data set? We would say no, it is symmetric. Okay. Now I won't keep this graphic on here, but I just want to show you this so you can see this visually. So if you think about graphing that bar graph, you're going to put those values 5, 6, all the way up to 14, because those are our actual data points. 5, 6, 7, 8, 9, 10, 11, 12, 13, and we needed to go all the way to 14. Now notice, I need to make sure I have a height. My y-axis has to get up to at least the highest frequency. That's 24. So maybe I'll count by fives. 5, 10, 15, 20, 25. So these are my frequencies, okay? And these are my items. my values. Okay, so 5 only occurred twice. So you draw just a little bar that has a height of 2, and we usually kind of cradle around that mark. So that's kind of the center. And then 6 has a height of 5. 7 has a height of 9, which would be just a little bit below 10. 8 has a height of 15. So we're just kind of drawing a bar graph to represent our data. How much data do we have in each group? 9 went up to 18, so that's a little shy of 20, but a little over halfway. 10 goes up to 24, so just a little shy of 25. 11 goes to 19, so just a little bit higher than that 18 bar was. 12 goes to 15. 13 goes to 10. And 14 goes to 4. So what you'll see is that is a very symmetrical graph. So this is graph A. I guess I can leave this here, but I just wanted you to see that matches with what I was doing. I was trying to do it without all the graphing work. You're absolutely free to do it either way. You can look at the frequencies, find the peak, and then count what's going on either side. That'll help you know if it's symmetric or skewed. Or you can physically put your values on the x-axis. Make sure you have enough frequency by counting by something on the y-axis, that's your frequency, and then graph each individual bar graph. It's a value, and this is the height of the bar, okay? So that will help you if you want to be visually about this. Now, just because I don't want to scroll down and then scroll back up, let's look at C. So C has 24 frequency, that's the item 9. That's going to be that peak, the highest point. And notice it's kind of similar on each side. So that really makes our whole peak. Your peak, like your whole peak is usually either 2 bars or 3 bars. So I'll show you a couple examples where it's just 2 bars. It's really how close are those values to each other, those frequency values. If they're very close to the highest one, we kind of include them in the peak, okay? Now, if we add up the ones to the left over here, notice we'll get 1 plus 1 plus 9. So that's going to be 11 items. If we add these up, that would be 13, 14, 15, 16 items on the right. And you think, well, those are very different. Well, in terms of what we mean by how different is too different, usually with Newton, as long as they're within 5 items of each other, they're going to consider it to be symmetric. So notice these two are within 5 items of each other, so they're going to consider this symmetric. So I did write a little note. So it's not skewed. It is symmetric because they asked, is it skewed? Um, they said that A and C are not when we did it in the Newton homework. So I just wanted to show you kind of their rule of thumb is that if they're within 5 items of each other, which if you subtract those two numbers, that's 5 items, then we consider it to be symmetric data. Okay, so we need a little bit more of a spread of difference for it to be skewed. Okay, so let's look at B. B has, this is the highest value, but what I want you to notice is that the peak is only 2 bars this time because 23 is very close to 26, but 15 is not. So this peak is going to be just a smaller peak, and that's because the two values on either side of the highest bar were not that close to each other, okay? Notice up here it was 18 and 19. Those are very close to each other. On the C one, they were both 20 on each side of the peak. So we included those as part of our like top of our bar graph, okay? Now we're going to add up these. So this is 17 items to the right of my data set, because remember, right is going larger on our values. And then to the left, which would be going smaller on our values, notice that this is, let's see, that'd be 27, 28, 29, 30, 31, 32, 33, 34. That is much more than a 5-item difference between the two sides. So this one is yes, because they asked, is it skewed? It is skewed. Oh, excuse me. And if you're wanting to know which direction, they don't ask you on these specific ones. It's whichever one you have more items on. So we would be, since this is going to the left, it's less than the middle values of 17 and 18. Then this would be skewed to the left. Okay. We're spread out more in that direction. But you just have to know that it's skewed for these specific ones in the homework. Okay. And then look at this one. This is my peak. And again, I would probably only include the 23 as my whole peak. And you do need like to look on each side because your peak is going to be not just 1 bar, it's usually 2 bars or 3 bars. And that depends on if the highest point is very close to either side. So it's closer to this one. It's within 5, but it's not within 5 on this one. Now, if we add up our left side, that's going to be 16 items, and they're all zeros and ones. And then if we add up our right side, we're going to have items that are 4, 5, 6, and 7. Those are the data values. But how many of them we have is, let's see, 24, 33. And again, that is a much more like despairing like value. This is way more than 5 apart from each other. So this one would be yes, it is skewed. And this time it would actually be skewed right. We have more to the right than we do to the left. Because remember, this is like the least number on the number line, and this is the greatest one in that group. So you could graph one of these as well, kind of like I did on part A, if you just wanted to see how that works out. Okay. Now we're going to continue into 7A.3. We're going to talk about creating or interpreting histograms, frequency, that should say tables, relative frequency. So a histogram, now I just showed you how to compute one on our previous example, but we're going to physically like define it. So in simple terms, it is a bar graph with continuous numerical data, no spaces between the bars. So if you look at mine, I didn't draw any gaps between my bars. They're all kind of just touching. That's why we kind of go halfway and straddle over that value so that all of our bars will touch. Okay. The height of each bar in a histogram will correspond to either the frequency or the relative frequency. So we're going to talk about what relative frequency means in a minute. Example of making a histogram. So we have, this is a table that was given to us. They had her Miss Nerd's class took a test. And so there were scores between 50 and 58. There was only one person who scored in that range. 59 to 67, there was nobody in that range. 68 to 76, 3 students. 77 to 85 was 5 students. And 86 to 94 was 4 students. That came from this list of data. So imagine actually looking, you have these list of like intervals that you're supposed to score them in. And you're just going up here and you're saying, okay, do I see any 50 to 58s? Yep, there's that one. So that's how that blue one came about. And then I look for the green. There are none in the 59 to 67. So then we look for 68 to 76. So that would be 1, 2, there should be one more. Yeah, 3. So 3 values. So that's how they're getting those frequency counts. And they were just doing them as tally marks, and then they converted them to numbers. And then once we do that, you put your score ranges as your x-axis values. So that's your labels. You put the frequency. We went all the way to 6, just went one more than what we had in our list. So 0, 1, 2, 3, 4, 5, 6. And then notice each interval, the bars are the height of the frequency. Okay. Notice this bar is here. It just is at 0. So there is no gap between any of my bars. It's just a very light green line down there. So now sometimes you'll be asked to make the histograms in Newton. They have like a really nice like Desmos interactive. Essentially, you just grab it's like a button on the center of each bar, and you can drag that up and down vertically so that it goes to the right height. So it's a very easy thing to do in the homework. Now, but a lot of times they'll already have a histogram made for you, and some of the questions are just going to ask you something about the picture. So it says selected runners from a marathon were asked how many miles they could run before they started to feel tired. The results are shown in the following histogram. How many of those runners could run greater than 7.5 and less than 8.5 before they started to feel tired? So greater than 7.5 would be going this direction, but they have to stay less than 8.5. That would go this direction. Notice there's only one bar right here that meets both of those conditions. So the greater than 7.5 and less than 8.5 is really only this group right here. So we go up to the height of that. That's going to be our frequency. And you just follow it all the way over. That's going to be, looks like a height of 5. So 5 runners. So if there's an and statement, you have to make sure you stick only in a group that meets both of those conditions. Okay. So look at my next one. Let's do a different color. Maybe we'll do orange. How many of those runners could run less than 6.5 before they started to feel tired? So notice there's no greater than on this one. It's just less than 6.5. So here's 6.5. Less than would go all the way to the end. They didn't have anything greater than to help us, stop at some point. So we're going to be just looking at these 2 bars. So we're going to add this bar height and this bar height. So this one was a 5 and this one is a 4. So that would be 5 plus 4 because there's 5 runners in the first bar, 4 runners in the second bar. So that would be 9 runners. So you just have to make sure you can interpret what they're asking, and then it's just counting those frequency heights of the bars that you need. Okay, so frequency tables part 2, tie it into probability. We're going to look at a frequency um, table that's already created, and we're going to answer some questions. So this is a 8-point quiz that 30 students in his class took. So notice this is 30 different scores, not in any specific order, just 30 scores. And then someone already created, probably the teacher, a frequency table. So to create that, he had to put all the scores 0 through 8, and then he went through and counted. There were 2 zeros. He put a 2 there. Nobody scored a 1. There was 1, 2. He just goes through that list, marking them off as he counts. So notice nobody scored a 3 on the quiz. 2 people scored a 4. 3 people scored a 5. 2 people scored a 6. 4 people scored a 7. And 16 people made a perfect score of 8 out of 8. Okay, so how many times does the data value 7 show up? That's just its frequency. So how many is frequency? Okay, so there were 4 students who had a 7 on their test. Of the 30 students, how many scored greater than 4? Okay, so greater than does not include the 4. If they'd said greater than or equal to, we would have said 4 and above. This is just their score is greater than 4. So that's going to be 5 and up. So we're going to go over here and mark that on our table. These are the scores, remember? These are not the number of students. This is how many over here. The frequency is the how many people were in each category. So we would be adding 3 students plus 2 students plus 4 students plus 16. I'm getting 25 students. Okay. All right, and what percentage of the students scored better than a 4? So that's the same question here, except instead of just saying how many, which is frequency, they want it as a percentage. To turn these into percent, and this is going to lead us into something called relative frequency, you take the number of items in the group that you wanted, so the ones who scored better than 4, we just found that on the last group, you divide it by the total number of people who took the quiz. So that was 30 students. So if we do 25 divided by 30, that gives me roughly 0.83 repeating. So they didn't tell us what to round to, so let's round to the nearest whole percent. So that would be times that by 100, that's going to be roughly 83% of his class scored in the 5 or better, essentially, range on the quiz. So they did pretty good. Now, a relative frequency table takes that idea of that very last step that I just did, taking the number of items that are in your group and dividing them by the total number of items in the whole data set. So frequency is just how many items fell in each category, like in each data value. But the relative frequency is what is the ratio as a decimal for how many people were in that group. In other words, it's the percentage of people in each group, but written in decimal form. So we just do how many items we have in a group, and we divide that by the total number of items in our data set. Okay, so let's look at this. And then there is one more other thing. I'll talk about cumulative relative frequency once we get the whole thing filled out. So the frequency table shows the number of goals that Real Madrid scored in each of their soccer games in April and May of 2016. Given the frequency table below, which of the following is a corresponding relative frequency table? Find the relative frequency. Okay, so notice they scored 0 goals, 1 goal, 2 goals, 3 goals, or 4 goals. So that is just how many goals were scored in a game. This, or for the whole game. So this is how many games where they scored nothing. There were 2 of those. There were 4 games where they only scored once. There were 6 games where they scored twice. There were 4 games they played where they scored 3 times, and only 2 games where they scored 4 goals. Now, the total number of frequencies, this column right here, this is how many games they played. Now, if I already added that up right here, they played 18 games. So this first one, 2 out of the 18 games they played, they scored 0 goals. So notice I did 2 divided by 18 and got 0.111. I just rounded it to 3 decimal places. They'll be very specific on the questions. They'll tell you what to round to. And then this one, there were 4 games out of the 18 total games where they only scored 1 goal. So if we divide 4 by 18, this ends up being 0.222 if we round it to 3 decimal places. There were 6 games out of the 18 where they scored 2 goals. So 6 divided by 18 is going to be 0.333. Now, this one's the same fraction we just had a minute ago. There were 4 games out of 18, so we already did that. That's 0.222. There were 2 games out of 18 where they scored 4 goals. So it's very unlikely for them. They're more likely to actually score just 2 goals in a game. That seemed to be the most frequent. And then the scoring no goals at all and scoring 4 goals in a game, those were more rare. Okay. So this is the relative frequency. In other words, it's like 11%, 22%, 33%, 22%, 11%. That is kind of like telling you what percentage of the time in the games that they played did they score this many goals in a game. Okay. So if you add this column up, it should equal roughly 1. Now ours ends up being point, I think 999. That rounds up to 1. So it's sometimes because we rounded some of these fractions and decimals off. It might be 0.999 or it might add up to 1.001, but you should be roughly right at 1. Okay. If you're like at 0.89, you're missing something. All right, and then this is called the cumulative relative frequency. So this is just all we're doing is now we're adding those percentages together. So at the first row, it's just whatever you got for that relative frequency. When we get to this next step, we're saying, what percentage of the games did they score 0 or 1? So we're actually combining the 2 rows. So that would be add the previous total plus the new percentage. That's going to be 0.333. Okay. Now we bring down that answer. So previous total, add the percentage for the row that we're currently on. Now we're at 0.666. So notice if you wanted to give this some kind of reference, you would say, okay, in about 67% of the games that they've played, they scored either 0, 1, or 2 goals because we're accumulating all of those values. Okay. Then we take that total and we add the new total here. This is for this row. That's going to be 0.888. And notice your last one should be almost that 1, that cumulative. We've almost either we have equaled exactly 1 or just right over it or right under it. We're very, very close to 100%. Okay. So that is a cumulative relative frequency. And I actually did put that down here. So the sum of all the relative frequencies is, remember we said, supposed to equal 1. Okay. All right, so let's look at this one. It says the data set is summarized in the frequency table below. Using the table to determine the number of occurrences of values greater than or equal to 7, give your answer as a single number. So this is just your directions on how to type it in Newton. For example, if you found the number of values was 33, you would enter 33 into your Newton, okay? But we're looking for greater than or equal to 7 for the value. So we want to know how many, which means frequency, of the scores were 7 or higher. So 7 or higher, so this is for part A, we would be adding up. There were 4 of the 7s, there were 4 of the 8s, there were 6 of the 9s, there were 8 of the 10s, there were 4 of the 11s, and there were 5 of the 12s. So let's see, that's 8. I'm just kind of adding as I go. 14 plus 9. That's going to be 22 plus 9 or 31. So we're 31 items in the values of 7 or higher. Okay, so let's do a different color for the next one. For B, oops, didn't change colors. For B, we want 5 or less. So how many, that means count the frequencies, are 5, less than 5. They didn't say 5 or less, just less than 5. So that's actually not including 5. So that would be 4 and below. So those are the scores. Here's how many there are. So that would be 1 plus 2 plus 1 plus 2. So that's going to be 6. And then for the last one on this one, let's do purple. At least 9. At least means that is greater than or equal to. Like if I say I have at least $9 in my pocket, I have $9 or more. So that's going to be just the 9 to 12. So that would be 6 plus 8 plus 4 plus 5. That's 14 plus 9, which is 23. Okay, so you're really just counting the number of frequencies that match to the group of values that they tell you to look at. Okay. All right, that is going to be the end of this part of the video.